Welcome to Backend Decoded. In this series, we decode the thinking behind backend interview problems. I will be solving these problems using Go, focusing on clarity, structured thinking, and interview communication. As a foundation, I am starting with an easy problem. From here, we will gradually move through the lead code 75 list and build strong problem solving skills step by step. Today, we will begin with one of the most common interview questions to sum. We are given an array of integers nums and integer target. We need to return the indices of two numbers such that they add up to the target. Important constraints: we cannot use the same element twice. We can assume exactly one valid answer exists. For example, let's go to the editor. We have For example, we have an nums array containing elements 2, 7, 11, 15 having indices like 0, 1, 2, 3, and target is 9. So here, how do we calculate the target here? So 2 plus 7 is equals to 9. So here we basically need to return the indices of 2 and 7, which is 0 and 1 here. Okay, so how do you approach this question during an interview? Before jumping into coding in a real interview, I would clarify: is there exactly one valid solution? Can the array contain negative numbers? Are duplicate values allowed? These clarifications demonstrate structured thinking and professionalism. Let's move to the approach. The most straightforward approach is: check every possible pair. For each element, compare it with every other element. If there is some equals the target, return their indices. This is completely valid starting point in an interview. Let's implement the brute force solution first. Let's write the function signature given in LinkedIn, sorry, lead code. Target int, and we need to return the array of integer. So here we basically need two nested loops. The first one will be run from 0 to length, and the next will be run from I plus 1 to length. So why do we did this I plus 1? Because if you remember the constraint, we are not allowed to uh, get the duplicates in the answer. That's why we are not uh, uh, doing the comparing the same element. So that's why for each I we are keeping I plus 1 as a starting point to the next nested loop. So here, now we inside that nested loop, we simply we had to do is simply compare the target with the nums of I plus nums of j. If it is equal to target, then we simply has to return the indices of that number, which is I and j, and get simply return the nil here. Okay, let's run this program. Okay, we haven't declared the main function, so simply declare the main function here and call the actual function from the main function. Okay, Here the array is 2 7 11 15, target is 9. Okay, and now we can run. Okay, so our program has written the indices of 0 and 1, so which elements are present in 0 and first location, which these are 2 and 7. So 2 plus 7 is equal to basically 9. Now let's calculate the time complexity. We are using two nested loops, so the time complexity is order of n square. Space complexity is order of 1. Since we are not using any additional space at this point in an interview, the interviewer will typically ask, can you optimize this? So let's analyze what we are actually doing. For a given number num, we are trying to find another number such that, for example, let's say current num is basically 2. Okay, then what we are doing here is we are trying to find the another number which, let's say, for example, the current number is num, and then we are trying to find the other number and checking if that num plus other is equal to target. Okay, for example, if current num is 2 and the other num is 7, then the target becomes 9, right? This is what we are doing right now, which means other is equal to target minus num, current number. This will also give the same result, right? Instead of searching the entire array again for that value, we can directly compute what we need. This observation leads us to more efficient approach. The key idea here is, as we iterate through the array, for each number compute its complement. So what is complement here? Complement is basically target minus current number. Check if that complement has already been seen. If it exists, return the stored index and the current index. Otherwise, store the current number in map. This is known as complement lookup pattern using HashMap. What is the pattern name here? Complement lookup pattern using HashMap. Right. For example, let's say we are iterating through the array and we are at index 0. Okay, which is basically 2. We will first check target minus current element. Basically, what is target minus current element? Target is 9, current element is 2, which is basically 7. We will be maintaining a map and we will check in map if that 7 already exists in map. If it exists, then that means 2 plus 7 is equals to 9, right? Okay, so in the if we during the first iteration of the first element, we'll get that 9 minus 2 is 7. We don't have anything in map right now. Okay, now what we do is we will add this 2 in our map. So let's say this is our map. Okay, then we will be adding 2, which is basically, and the value here key will be that will be the number, actual value present in the array, and the value will be the position of that element in the array. So position is here is 0. Okay, let's say we are iterating and we are now in the next position, which is 7. Okay, so let's run the same formula. What is our target? Target is 9 and current number is 7. So 9 minus 7, basically, what is 9 minus 7? 9 minus 7 is 2. Okay, now we will check if that 2 is already exist in the map or not, and here we are we get to know that the 2 is exist in the map. So that means we have an pair like 7 and 2. 7 plus 2 is basically 9. Okay, so we in this case we simply return the indices. We don't have to continue iterating through an entire array. So that means we don't have to iterate an array multiple times. Like we don't have to do some nested for loops here. So now let's build the optimal solution. Let me write the separate function for the optimized solution. Optimized signature is basically nums int target int return value array of int. Okay, now we will be generating one map. Let's use make to initialize that map of intent int. Here basically the key will be the actual values present in the nums array, and the value will be the indices, and then we will be iterating to the nums array. Okay, now let's calculate the complement. So how do we calculate the complement? We already know complement is basically target minus current number. So here complement is equal to target minus current number is num, right? If now we will check if that complement is basically present in our map or not. Here what we are doing basically is we are checking if we have already seen that complement number or not. If it is found, then we have an pair. Simply return the index and the I. Okay, if let's say if complement is not present in the map, then simply add on the current number in the map. Okay, and the value of that num will be I, which is basically an index, and simply return the nil at the end. Okay, now let's change this to call the optimized function, and let's run the program. Okay, so here we are seeing the correct output 0 and 1. So important detail here, we check for the complement before inserting the current number into the map. Time complexity here is order of n, since we traverse the array only once. Space complexity is order of n because we store elements in the map. What this question actually tests, this problem is not just about using a hash map. It tests whether you can start with a brute force solution confidently, whether you can analyze time complexity, whether you can identify optimization opportunities, whether you can clearly communicate your reasoning. Many candidates lose marks because they jump directly to coding without explaining their thought process. Always ever explain your thinking clearly during interviews. So how you could summarize your solution in an interview? So if I were in that position, I could summarize this solution in for example in this way. I would start with a brute force approach, checking all pairs, which results in order of n square time complexity. However, we can optimize this using a hash map to store previously seen elements. For each number, I compute its complement as target minus current value. Target minus current value. If the complement exists in the map, I return the stored index and current index. Otherwise, I insert the current number into the map. This reduces the time complexity to order of n with order of n additional space. This problem introduces the complement lookup pattern, which appears frequently in coding interviews. In the next videos, we'll continue solving problems from the LeetCode 75 list and build strong backend interview foundation using Go. Thank you for watching.